Hello and namaste everyone. Welcome to inaugural edition of CloudNXT 2022, Globant's premier web conference on cloud and DevOps. CloudNXT 2022 is all about embracing your cloud transformation journey along with DevOps practices and innovative capabilities. CloudNXT is a 2 days web conference which will have very informative talks about cloud transformation, architecting applications, DevOps toolchain, and many more interesting topics. We are your host for the conference. I'm Lovely Mirchandani and I'm Cloud and DevOps Engineer at Globant.
Hi, I am Anjali Gaur and I am Cloud and DevOps Engineer at Globant. And today we welcome you to at our CloudNext 2022 conference. Facilitating efficient ways of doing business through innovative DevOps practices is the main agenda for this CloudNext conference.
Before we begin our exciting journey, here are some important points to remember. First, throughout the session, if you have any queries, please share those on chat and our speakers will answer them. Second, please keep posting with the hashtag CloudNext2022 and tagging Globant in India on LinkedIn. Most liked and shared LinkedIn posts may get a chance to win some exciting goodies.
We would now like to kick off CloudNext 2022 with a quick address by Shivraj Sable. Shivraj, fondly known as Shiv, heads Globant's India Talent and Delivery Center and focuses on the expansion of transformation capacity at Globant at the APAC and EMEA region. One of the focus area for Shivraj has been around readying capacity to take up digital transformation challenges. Welcome, Shivraj.
Hey, folks, a very good evening to all of you, and a very good morning to those in different time zones. I really want to welcome you to this amazing web conference. We have been hosting this within Globant for the last few years, and it's really encouraging to see such amazing response across all the different technologies when we host the next conference. Firstly, I would like to congratulate each and every one of you to really spend and invest this time in yourself. I'll come to the point why it's important to do that. And so, firstly, congratulations on really finding time to really spend time and invest in yourself. Okay. Now, to give you a little bit of snippet about Globant, it's very important to understand what has been happening with the whole industry so far. We have moved on from digitization to a more digital upgrade era where we've started moving from obviously on-prem to cloud to all the other aspects of upgrading your softwares because of advent of good hardware. But now what we are seeing is a need for a true transformative let's say engagement with customers so that we can truly create solutions and business solutions which will transform the nature of the business itself, right? So we have a lot of industries who need this kind of transformation. One example that I keep asking people is when was the last time you went to a bank branch, right? Or when was the last time you really thought Uber was a software company? It's a pure software platform company. It's not a taxi company. Some of these questions will make you realize that the disruption that is happening is all across. Disruption is in media and entertainment. Disruption is in the way we do our banking, media. It's in disruption is in every single aspect, right? From education to let's say insurance. So we are looking at disruptions in every single phase. So I think it's very important for us to focus on what kind of solutions we can create to make our partners or industry partners relevant for the next 20 years. And that is where there is going to be a big change in the kind of skill sets and the big change in kind of solutions that we create. For that to happen, you have to understand what is happening in different eras. For example, what's happening on cloud. Today, you're going to spend some time understanding, learning, listening to things which are really going to help you with some food for thought. We don't expect to give you solutions. We don't expect to give you the answers in the next few hours. We expect you to get some ideas and get some new food for thought. This allows you to start thinking what's next, right? I think, for example, in cloud, we've seen there's been this back and forth with edge computing, back and forth with cloud computing, and then we don't know what's next because, with more and more processing power coming on edge devices, we're seeing let's do more edge computing. But then at the same time, we are seeing much better and reliable networks, thinking why can we not do some of the critical tasks too also on the cloud. So I think there is a certain level of uh, dynamicity in which where this whole industry is moving, but at the same time it's always good to be on the leading edge. What I would definitely urge all of you is participate today, ask as many questions as you can, and most importantly, be open for newer ideas. I think this opportunity is going to give you a really good, uh, let's say, eye opener. It's going to give you some new ideas. Let's make the most out of it. Start thinking what's next in terms of cloud. And I think I don't want to take up a lot of time from all of you because I know there is an amazing lineup of speakers after this. So let's get into it directly. For those who've just joined late, very quickly, my name is Shivraj. I'm the head of Globant India, and I want to welcome all of you to this amazing web conference. And I hope you make the most out of it of the next few hours. All right. Thank you so much for joining in on a busy evening, and welcome to this amazing Cloud Next. Thank you.
Thank you, Shivraj. Now it's the time for our first talk. And let me introduce our first presenter, Facundo Tomaselli. He is Technical Director at Globant and is passionate about leveraging the latest technologies and methodologies in the digital and cognitive space to help organizations transform.
In this talk, we will be finding more about what the cloud is and will continue to be, a highly relevant strategic consideration in company growth plans for years ahead. To address this, in Globant, we have developed a vendor agnostic enterprise cloud transformation framework. So, with this, let's hand over to our first presenter of the day, Facundo Tomaselli.
Good morning, good afternoon, good evening, everybody. My name is Facundo Tomaselli. I'm a Senior Tech Director here at Globant, and I'm going to be talking today about our approach to cloud transformation. So to begin with, just a quick summary and overview of our studio, the CloudOps Studio. As of today, we're a studio that has over 1,200 CloudOps engineers globally. We are distributed in 15 countries, and we are supporting cloud transformation for over 170 clients. What we do basically is everything related to cloud and DevOps. Here in Globant, we organize our studios in what we call the practices. And you will see there in the middle of the slide that we have like two big areas or parts of our practices, how we group them. The first one, which is the one that I'm going to be talking about today, is Cloud Transformation Framework. You will see there that the Cloud Transformation Framework is composed of 4 different practices: the advise, the build, the move, and the operate, which I will talk a little bit more about it later. And then we also have the adopting a CloudOps mindset, which pretty much interacts and cross with the cloud transformation framework on different stages. And I know that on different portion of this event, we will be talking about them as well. So you can see there in adopting a CloudOps mindset, we have DevOps cultural change, site reliability engineer, and chaos engineering, which I do know we will have a special session conducted by our studio partner that will talk about that. One thing about Globant is that we are technology agnostics. So there you can see just a glimpse of the technologies we have. You can see AWS, GCP, Azure. We also have partnerships with many other cloud providers. And we, as I mentioned, we are technology agnostic. So we have people certified in all the different vendors. So not only cloud, but also several DevOps technologies. And just as a number you can see there, we have, as of today, over 700 Globers that are certified in cloud and DevOps technologies. So we're a studio that is growing. Last year, we have a growth rate of 54%. So we are more and more, and we're expanding on all the different geographies. So this is just a quick glimpse of our studio in general to have a good understanding. And I will just go right away to the Cloud Transformation Framework. So Cloud Transformation Framework. What we have done here at Globant is put together a framework It's not only something that we put together, but something that we validated against the industry about with major consulting companies. So to mix and match and validate whether our approach was something that the clients were actually looking for, right? So you can see here that we put sort of a journey that help us accelerate cloud transformation for our framework, for our clients. So we have this in these 4 different phases. The first phase, which is the advice, are basically the consultancy services. Enterprise cloud transformation strategy is working with the client how they will transform to cloud. Okay, so this is not the execution, but putting a roadmap together. And the good about advice is that it's not technology alone, right? It has, and I will go into more details into additional slides. It goes into 4 key dimensions that are key for a successful cloud transformation. The first one, of course, is technology, right? The one that you may know, and you will all know about that technology is going to be core, because this is what we're talking about. But there are 3 additional key areas which normally not many companies understand they need to go through in order to get a successful cloud transformation. One is process, right? You need to be able to modify your process, because it's not the same to be on-prem to be on cloud. So there are going to be changes in technologies, and there's going to be changes in process. There's also going to be changes in people, right? There's going to be a transformation in the skills. The type of skills that you need when you are operating something in a traditional legacy on-prem environment, and when you are moving to cloud, and even though when you are doing an evolution on your cloud adoption, not only being in cloud, but doing an adoption of additional technologies, that will require for people to transform. And then last but not least, business, right? Business. Why? Because the cloud transformation is something that is pervasive for the business. So basically, you need to make sure that your cloud transformation will support your business, will accelerate your business, and also that the business can, if you want to call it informally, pay for it, right? Because there's going to be an investment. There's going to be an investment, and you will need to have people that talks business, so to make sure that you clearly understand your return of investment, how long you want this transformation to take. Do you want to be in cloud in 3 months, in 6 months, in 1 year, in 5 years? Which are the areas that you want to do that, right? So these 4 dimensions, as I mentioned, and let me recap: technology, people, process, and technology are the 4 dimensions that we consider critical for a cloud transformation. And that's basically what we do in the advice, which I will go into a little bit more details in the upcoming slides. Then we have build. Build is building in cloud, building native in cloud. We do a lot of that. That's historically what Globant has been doing the most, because when Globant started almost 20 years ago, it was a software development company. So basically, most of the projects were developing new software, developing new applications for our clients. So we started very early, over 10 years ago, building in cloud directly, building in cloud when AWS was just on its very first steps. So we have engineers that have been doing cloud for over 10 years now, putting applications directly on cloud, right? Infrastructure directly on cloud. Then we have the move. The move is, or migration, if you want to call it that easily. People talk about migration, is moving to cloud, right? Whether moving to cloud, it can be moving from on-prem to cloud, or even moving from one cloud provider to the other, right? Doing an analysis whether there are some capabilities that you need in order to adopt a multi-cloud strategy. Maybe you need to move some components or some workloads from one cloud provider to the other cloud provider. So we can help you with that as well. And then last but not least, operate. And operate is, okay, you are already in cloud. However you are in cloud, whether you have done, you are fully adopted and you are using all the benefits of cloud, or if you are only using infrastructure as a service and maybe you just move a few workloads or initial workloads and you need someone to operate that for you, we can do that as well. We have different models to do that, with FTEs, with a shared service model, but basically it's doing the operation. And again, these are not silos, so each of these areas are not silos. So they sort of cooperate one with the other. So operate can tackle an additional build, or from operate, it can tackle an additional move, right? So they sort of go hand by hand. And of course, then the governance, which we don't consider a phase because it's like the overarching governance, building a cloud center of excellence, depending, of course, of the size of your engagement. It's something that we think is extremely important to have. So to make sure that when you are doing or when you're executing your cloud transformation, you have a cloud center of excellence, which is putting together the guidelines and making sure that you have a good governance of your cloud transformation. Okay, moving on. Okay, and this is just a double click of what I just mentioned. As I said before, our cloud transformation frameworks, we think it make us the right partner to lead our clients' transformation. And what we have done here is what I just mentioned before, but you can see we have this split in two different tracks. And by tracks is like you can do your cloud transformation, whether you will start from advice for sure, right? Ideally, something we will do for you. But let's say that you already have done that. You have already done your analysis. You know where you want to go to. You know how you want to go there. So you need someone to do it, right? So it differs whether you are doing a cloud native transformation or you are doing a cloud journey transformation. And when we call a cloud native or cloud journey is, let's say that you are a startup or you are a company that is just starting, or you are even a corporate, a large corporation, but you have maybe a new business unit that is sort of detached or can be detached for your traditional on-prem environment. So you will have a cloud native track, right? So we will build directly on cloud for you, right? We're not talking about the migration. While the other track, the cloud journey migration, is what I mentioned before about the migration, right? You are on-prem, you need to move, or you are in one cloud provider and you need to move to another cloud provider. There are many reasons why this may happen. Sometimes there are M&As in which companies you have the parent company, which is in, let's say, AWS, and the acquired company is in Azure. So from a corporate strategy, they need to merge that together. So they need to move. So it's not only the traditional on-prem move, but also moving across different cloud providers. And also not only things like what I just mentioned, but it can also be corporate decisions, right? Or even strategic decisions in terms of, I want to leverage for data. I think GCP is better. So let's use these because the capabilities I have there are maybe more cost effective or more advanced than those in AWS, in Azure, GCP, IBM Cloud, or whatever, right? And one last note of this, I'd say operate. So you can see here we have these two different tracks. So advise, build, and operate, which is the cloud native track, and advise, move, and operate, which is the cloud journey track. Up there in the upper right corner, you will see, I don't know if you see it here, if you see my pointer, we have these with different flags. That's a white paper we put together. It's very concise. It's less than 10 pages. It's very straightforward to read and understand. And it has been translated into 5 different languages. So we encourage you to download that white paper. It's available on globant.com. We can definitely provide you the link after this. It basically gives it's intended for clients directly, for business areas. So it's not something that is only technology related, that you need to be in technology to understand it. And so it sort of summarizes the approach we have for cloud transformation. Pretty much what I'm doing here, but in a nice reading format that you can just download and read it directly on your computer, your Kindle, or whatever. So I encourage you definitely to take a look at that. I think it will help you understand our positioning on how we do cloud transformation. So this slide, I will just move to the next one, but you can see in each of the areas, we have a very quick summary. So again, the advice is review and analyze the current landscape and understand what are recommendations to select the path forward. The build is where we identify the requirements and we construct all the foundational platform tool set, everything that is ready to support the software development lifecycle. Then we have the move, which is preparing the applications and all the ecosystems and tools in order to migrate them largely as is to cloud. We will talk about that later a little bit. And then the operate, which through a dedicated or shared service model, we can operate your cloud environments. Okay, I will double click a little bit more in advice, given this is the one that maybe is not more technology related or the one that will include different dimensions. So it might require some additional timing. Of course, depending on the audience, some of the things I will say maybe in build or move are more technology related or something you are more used to. to listen to, but in this one in particular, I think it's important we stop a little bit and we spend a little bit more time. So advice, as I mentioned, is the initial phase for cloud transformation. Is where we help the client through our consultancy service understand how they can go through a successful cloud transformation. So what you see in this slide is we have in the left the program inputs. The summary is not everything there, but just a summary of what are the things that we are going to be putting as an input that we're going to be extracting from the client in order to then sort of chew it through different stages of the cloud transformation. You will see we have those 5 small logos in the top are basically 5 sequential steps that needs to happen for a successful cloud transformation. And then you will see that each of these areas, these lanes or these rows that you see there with the different areas, you have these fancy logos. So for those that are not familiar with those logos, those are the logos of our studios. You can see the first one that says hybrid cloud architecture is that this is the CloudOps logo, and then you have some additional logos of different studios, and I will explain the reason behind that. So to get started, you will see program inputs. So just a quick summary. Application inventory, for sure. We are not talking about only about cloud, right? We are talking about the portfolio of applications. We need to understand the workloads. We need to understand how we will put that into cloud, right? Then integration model, security and compliance requirements, right? It's not the same to be on-prem, maybe in one facility on your in a country where certain regulations are there, and maybe you're moving to cloud. You need to make sure that you can. You need to make sure that it will follow all your compliance guidelines. If you have any regulations like GDPR or industry-specific regulations, you need to make sure that you're going to be compliant when moving from on-prem to cloud, right? Reporting and analytics, understanding your reporting and how that will happen if you have a data warehouse and you need to move to cloud, how that will continue doing. Infrastructure inventory, for sure, that's something that from the CloudOps Studio will be key to tackle to understand your if you're going to be needing either bare metal servers or if you can move directly to VMs or if there are some additional technologies that you can adopt when moving from on-prem to cloud. Operating model, that's related, and you will see there one of the studios, the Agile Delivery Studio, that's related to the dimension of people that I was just mentioning before, right? So you're operating one way when you are on-prem, you will be operating differently when you are on cloud. So understanding your current operating model will help you change it accordingly to make sure that it's aligned to to the cloud, to move into cloud, right? Skills and responsibilities, for sure, understanding the different teams, the different stakeholders, who is responsible for what. When you are moving a workload, there are different areas that are impacted. If it's a workload that is client-facing, it might require maybe a different phase approach so that you don't impact production. So understanding that is key. Then financial data, and this is what I talk about business. You remember that I mentioned 4 different dimensions, one of them being business. So it's key that we have understanding on when we do the cost benefit analysis on how you can support this cloud transformation, right? As I mentioned before, you want to do it in 3 months, 6 months, 1 year, 2 years, 5 years. So depending on how how much your business can invest in this cloud transformation, that will modify the speed of this journey, right? And then, of course, any in-flight programs or projects that you have, maybe you are near a go live, and in order to have a go live, you need to make sure that, well, let's finish with this before I move on. So also important to understand that. And last but not least, executive perspective. We do interviews, interviewing with the different stakeholders within the company, making sure that we are all aligned. Because again, this is not a technology discussion. This is technology, this is process, this is people, and this is business, right? And these 4 dimensions match to our studio model actually into 5 different studios. So recapping to what I was mentioning a few minutes ago, we have the hybrid cloud architecture lane, which is owned by the CloudOps Studios, those here in this event, the CloudOps Studio. Then we have security and compliance. This logo stands for the Cybersecurity Studio. We have a Cybersecurity Studio dedicated specifically for that, with ethical hackers, with security officers. So people specialize in regulations, specialize in security, that will make sure that your cloud transformation is aligned to your security and compliance regulations. Then portfolio transformation. This stands for the Scalable Platform Transformation. In Scalable Platform, we have a practice for portfolio transformation. And this means understanding what your portfolio of application looks like today, do an analysis of that, understand who are the stakeholders, what's the investment level that they have, what's the impact to internal clients or external clients in that case, and also prioritize, right? Is this a workload that we will deprecate? Is this a workload or application that will stay on-prem? Is this a workload that will be refactored in order to move to cloud? So there is where you define sort of potential reference architectures, right? And your potential reference architectures will be the ones that will define what's going to be the architecture that you will need and the security and compliance that will come with it, right? So that's why portfolio transformation and having software engineers from our Scalable Platform Studio is key for a successful cloud transformation. Then we have the target operating model. As I mentioned before, this one is tackled by the Agile Delivery Studio. We have an Agile Delivery Studios with Agile coach, with people with a lot of experience in delivery. So making sure that we can tackle this transformation. So what's the current operating model and what's the target operating model, and how we can do that transformation in people is in people and in process is key. So those two dimensions are tackled by the target operating model lane, which is owned by the Agile Delivery Studio. And then last but not least, cost benefit analysis. That falls under the Business Hacking Studio. Business Hacking Studio is a studio we have with consultants that hack the gap between business and technology. So, and this is exactly that, right? Understanding, okay, what's going to be the cost of doing this cloud migration? What's going to be the benefit of doing this cloud migration from a financial standpoint? And then putting together different scenarios, right? Putting together different scenarios or financial simulations. We'll say, okay, if we do it in this amount of time, we will stop paying this type of licenses, this housing bill, and this electricity, and we will be not having any more this on a traditional data center. Okay, but now you will have whatever it is that you are using or consuming in your public cloud provider, right? So understanding that and doing the match between your expense, your IT expense in on-prem, which it may differ, right? Because basically here you may be heavily invested with CapEx, and when you shift to cloud, it's going to be more on an OpEx model. But having that understanding, having that discussion, understanding your financials and how this will benefit your company, so you know when this will pay back, is also key. So again, a holistic approach that is supported by the Globant Studios model. If you know about that, we have over 25, maybe 30 studios now with different technologies. These are the 5 studios that are supporting cloud transformation, but definitely we can also have additional studios if there's a specific need. I don't know if it's a life science company, right? We have a life science studio. If it's maybe a gaming company, we have a gaming studio. So for the different studios, we can also have support from those studios that are specialized either in specific industries or specific verticals or specific areas or topics, right? Okay, so I already mentioned the inputs. I already mentioned how our studio model helps support a cloud transformation. So you will see above are the 5 different sequential steps that need to happen for a cloud transformation. But I will go into details in the upcoming slide. So with all these inputs, with all this work here in these 5 sequential steps, you will be ready for the cloud transformation. So the output of this is going to be a cloud transformation roadmap, which will enable to then define whether you are going to be moving to a build, right? Like building directly in our cloud, or we are going to be doing a move because it's a migration, the one what we are talking about. Okay, moving on to the next slide. Okay, so for each of the 4 different phases of the cloud transformation framework, we have different steps. So as I mentioned before, advice, and I will go into details a little bit more later. we have these 5 different steps. The 5 different steps in this case are sequential, so you need to go through all of them. And I'll show you in one of the slide a little bit more on how they connect one with each other and what that means. But that's not maybe the case for all the different steps of the cloud transformation. I'll show you that, for example, in move, it's not sequential. Actually, you can move to one and then you are out. Same with operate, is sort of more of a continuous approach, the one that you will see in operate. And we have put together some visual graphics of how this path goes from one step to the other. So maybe I'll just give you more details here, so then I can move to the other slide. But these 5 steps on the advice, they start with the review current state. Review current state is basically the as-is. So gathering and evaluating everything, all your IT assets today, like from applications, from infrastructure, also, as I mentioned before, cost. So we will be trying to understand everything as is today. So how things are looking for you today. Then we move to the next step, again, sequential, which is analyze and compare. Analyze and compare, if you want to summarize, is the to be, right? So analyze what you have today to where you want to go to. So matching to the industry best practices and to cloud best practices. So also aligned with the cloud adoption framework of the different public cloud providers. So it's okay, what are the things, so from where you are today to where you want to be, how long you are on that trip, right? So understanding your your maturity model in each of those areas. Once we finish with the analyze and compare, so basically the to be, we start with maybe the step that is going to be the most time consuming, and that it requires a lot of different stakeholders to interact, which is creating alternatives. So when we create alternatives, we talk about different scenarios. So different scenarios means, let's say that we identified, I don't know, 50 workloads, right? That you need to migrate to cloud. So maybe those 50 workloads, when we define we need to move them, we find out that there are maybe 5 that for, I don't know, because of some regulations, you cannot move, right? And maybe there are some 5 additional workloads that you define, hey, maybe these ones I will deprecate, or I will continue having them in legacy, and I will just build something new in cloud to replace those. And maybe there are some others that you are going to be defining specifically, like, yes, we want to refactor them and we want to move these ones to cloud. So the different scenarios will basically give you different potential reference architectures, right? So one reference architecture, just to summarize it, might be 70-30, right? I will stay 70% on-prem and I will only move 30% to cloud. Another scenario can be 50-50. I will keep 50% of my workloads on-prem and I will move 50% of my workloads to cloud. So for each of those scenarios, you will need to go through all the different areas that we analyze and see, is this compliance with security regulations? It is. Okay. Is this aligned to our portfolio transformation strategy? So it's aligned to what we want to do with all the different workloads? Yes, it is. Can I pay for it, right? Because benefit analysis, can I afford being on a migration for 50% of my workloads, but I still need to support things on-prem, also do the actual move to cloud and then operating that on cloud? Maybe not. Maybe you need to start with something small. Maybe you need to do a 70-30, as I mentioned before. Or maybe you can do 50-50, but one scenario can be doing it in 1 year and the other scenario can be doing it in 2 years, right? So all of these are the things that you need to sort of understand and tackle when you are creating alternatives. And you are not saying this is not a good alternative, right? You are defining the different possible scenarios. That's why create alternatives will end up with different simulations, financial simulations, maybe different reference architectures. Maybe one is, let's move these to this public cloud provider, and maybe another scenario is doing exactly the same but moving to another cloud provider. So all of them are different scenarios. Then once you finish, we just say, okay, we have enough scenarios here. We are comfortable enough with the different options we have. Then you have develop course of action. So the next step, develop course of action, is basically prescribing the activities in order to execute the transformation. So here, what will happen is that out of all the scenarios that you have put together, you will define which is the reference architecture of choice. Okay, so what's the path that we are selecting, right? We define 2, 5, 10, 20 scenarios. Okay, let's go with one. What's the one that our business can support, that our technology is aligned to, that our people will be capable of adapting to and adopting this cloud mindset, and also what the technology can actually achieve. So once you have all those areas tackled and agreed with the different industry stakeholders, client stakeholders, you will then define this is a go-to path. And then last but not least, chart your roadmap. So you have already defined what's the scenario of choice. You start in prescribing the activities. Okay, we now need to finalize this, put it down into a plan. Again, it's going to be an agile plan, something that will be, it's not going to be an endless Gantt, but basically a way, a roadmap where your different areas can understand where they need to go to next to start the cloud transformation. Okay, you will see that for each of the the different frameworks, we have these steps. I will go a little bit faster on the other ones because most of them are more, you may be more familiar with, because are more of a standard in the industry, what build, move, and operate are. And before we wrap up, I will show you these in a different sort of format so that it's more graphic than maybe this slide with text. I encourage you to either download the presentation or take a look later, because there's a lot of text here, but I think it's important if you're going to be seeing it on your own, or even better, as I mentioned before, download the white paper. I think definitely that's going to be a good way of telling this story, right? So moving on to build. Again, this is also sequential, like I mentioned for advice. Just to recap, the build is what we call about think, design, and create a home for your next application in the cloud. So basically a cloud native track, right? Building directly on cloud. So no moving to cloud, but building directly on cloud. So you will see here in the 5 different steps that we have here, we'll start with managing non-functional requirements. So this is basically taking care of all the dependencies, understand what is needed and what is not needed for the final products, what are the features to be delivered, if there are going to be licenses, there are going to be cloud accounts that you need, there's going to be a third-party vendors and subscriptions. So all that is related to non-functional requirements. Once you have defined all of that, we start with building the cloud formation. So basically this is starting putting together all the things that you need as the pillars for adopting, for using cloud natively, right? So networking structure, connectivity, if you need to connect on-prem with cloud for something in particular, if there are any third parties that you also require for configurations like identity management. So building the cloud foundations before you start actually putting things in cloud. Implement toolset, the third step of the build, is installing and configuring all the tooling that you need to support your software development lifecycle. So definitely this is strictly related to DevOps, to your CI/CD pipelines, understand if you have that in place or you need to do it specifically here. So depending on the type of solution that you need, whether it can be open source or enterprise solutions, if you want this managed by your team, if it's going to be on us, it's going to be a shared team. So understanding all the tool set that you need to have in place, again, to adopt a cloud native track. Then step number 4 for build is leverage of the low level environment. So here you are actually now creating everything that is required for a pre-production environment to support a software development lifecycle. It can be doing some templates, it can be doing infrastructure as code. So basically all the requirements that you need to secure that you can eventually move to production easily or without impact, right? And then last but not least, the road to production. So you have your non-functional requirements, you build your foundations, you implement your toolset, your CI/CD pipeline, you leverage all the low-level environments. So now it's time for your road to production. So in these cases, I'm going to be having automation here. What are the different benefits of cloud that you will be adopting, being that you are building directly on cloud? Will you have monitoring? You will have observability for infrastructure. So this is going to be definitely, there's going to be an evolution here. You may go to production, maybe not adopting all the benefits of cloud, and maybe through different iterations, and even through the operate, right? When you are operating it, you can understand, okay, there's a new service. This service serves me better for the goal that I want. So then you can go back to build and well, go through these steps again as part of a recommendation from the daily operation of your cloud environment directly in cloud. So I will also share some slides about this later on a journey visual, if you want to call it that way, that I think will help also understand how we tackle this specific phase of the cloud transformation. Then we have Move. Again, for Move, I think the one of the visual slides that I have will be maybe a little bit better than this one, but definitely this one helps understand the different steps. And different to the other ones, this one in particular is not sequential, right? Definitely, you need to start with prepare, and maybe with the other slide that I will show about Move, it will be clear. So that's definitely the first step that you need to go to. But all the others already enable you for a cloud transformation, right? And what this means is that you can do your prepare, right? Basically listing all the applications, the databases, the VMs, any integration that you need, any profile or user profile that you need to migrate, any testing that you need to do. So preparing your environment for a cloud migration. But then you can just do a lift and shift, right? You can just migrate whatever you have, largely as is, to cloud, and that's it. And you finish your cloud journey, right? Of course, it's not the best. It's not the best way to get use of the benefits of cloud, but it's a valid way of doing transformation, and maybe it's just a step number one, right? So you can do a prepare, lift and shift, and then you are out of Move, right? And then you go straight to operate. You have your our team or your team doing the operation of what you have moved to cloud. But there are other options, right? You can do cloud evolution, in which you start using elasticity, agility, all the benefits of cloud computing. Also, you may start evolving your application so that you can take advantage of these capabilities. So that's cloud evolution, right? You are already in cloud. Now you need to do an evolution and make sure that you are starting to adopt new services, new features, basically clearly adopting the benefits of being in cloud. And last but not least, cloud optimization. So maybe you're already in cloud and you are developing new applications, new customers that maybe you have discovered a specific service that might be beneficial for you, or maybe new architectures that you want to try. So the idea of the cloud optimization is, let's drive efficiency and scalability to our workloads in cloud. So we have specific steps that can be followed in cloud optimization. Again, not a sequential step in this case. After prepare, all of them will take you to cloud. You will be in cloud. It's just a matter of how deep you want the adoption of cloud to be. I'm moving on to operate, the last step of our cloud transformation framework. So in operate, again, this is not sequential. You will see that we have these 4 key areas where we support. So we can do support as a service. People familiar with incident management, with level 1, level 2 type of support. So supporting your infrastructure in a 24/7 capability. We have a shared service where we can do that, or it can also be with people fully dedicated to you. Even some hybrid models, we have clients that they have a support team and they need us to help them cover the gap, maybe, I don't know, weekends or after hours, or maybe in some specific skill sets, even during business hours, that it's getting complex for them to have. So we can do that as well. So here basically is making sure that we can faster and efficiently close any incidents, and also an evolution here, right? Making sure that we tackle the actual reason, doing an RSA, and making sure that we reduce your ticket queue and that things evolve into a more stable environment, right? So we can do support as service. Then we have cloud and DevOps. So we have cloud engineers, we have DevOps engineers. If you need to operate and you specifically need to be focused on the pipeline creations, monitoring, tools integration, infrastructure as code, we can do that. If you need cloud specific, so cloud management operations, focusing maybe specific areas like, I don't know, we have the different pillars of the well-architected framework, right? We have people certified to do well-architected framework. So you need to focus maybe in cloud economy or maybe in resiliency. So we can do that as well through our operate team. And then last but not least, cybersecurity, which this sort of merges or interacts with our cybersecurity studio, which I mentioned before. As part of the shared service team, we can also provide cybersecurity. We can do penetration testing. We can analyze potential threats. We actually have an accelerator for this, which we may, if there are dedicated sessions for the cybersecurity studio, we will talk about them as well. So cybersecurity is something that we can also do as part of the operate. Okay, so this is just a quick glimpse about how we adopt cloud, or how we help our clients adopt cloud transformation, the 4 different steps. Just for you to have, I'm not sure whether it's going to be a presentation that you will be able to download, even though you can clearly see it here. For each of these 4 steps, and I will not go into details because I already spent some time in each of them in particular, you will see that we have what I mentioned before, sort of this visual. So this is just a high-level summary that you can see up there in the right up corner, that where we are, right? If it's advise, build, move, or operate, sort of a small map. So you can see very simple image of the 5 different steps within the advice phase, right? So you have the input, the 5 different steps that I mentioned: assist, to be, potential reference architectures, reference architecture of choice, chart your roadmap. You have your cloud transformation strategy, and then you can go to a build, or you can go to a move. So if you actually go to a move, this is how the journey continues, right? The 5 steps that I mentioned: manage non-functional requirements, build the cloud foundations, implement toolset, leverage of low-level environments, and then run to production. You are ready to use cloud. And then this will take you to operate, right? I will just jump very quickly to move, so to finish the other track as well, because they both end up on consolidating operate. So here, and this one may be a little bit loaded slide if you want, but I think it serves the purpose. You see what I mentioned before. You come from an advice, you prepare for a cloud migration, and those are some of the high-level steps of what happened during the prepare. And then you can do a lift and shift, and the lift and shifts can just be your final track for a cloud journey, right? From lift and shift, you move directly to cloud journey. You are already, you do a migration, you have mainly leveraged infrastructure as service here, and you are ready in cloud. But then you can move to additional steps that of the cloud move of move within our framework, which is cloud evolution. For example, here I mentioned adoption cloud, executing a multi-cloud strategy. So maybe you define here that certain workloads you need to, you prefer to move it to another vendor, to another public cloud provider, apply elasticity, auto-scaling groups, clustering, all of that. And then cloud optimization, like using loosely coupled architectures, microservices, well, different benefits of being on cloud. So all of them will take you to a successful cloud journey. And you can see here how this also connects with the operate. And what I mentioned before, operate actually is input for all the other phases, right? Because out of the operate, there might be the need of, hey, we are operating this, and we understand that because of this additional workload, it would make sense to move it to cloud, because through our support team, we're finding that 80% of the tickets are coming on this, are coming from this workload that we are supporting, that is on-prem. And if you move to cloud, like these other workloads that you have, it will definitely help you on improving service time, on reducing ticketings. So operate will be providing feedback, active feedback that can actually trigger additional phases, right? That's why these circle backs to move. Same happens with build, right? And then last but not least, operate. As you can see here, is sort of a round circle, because this is something that that is a continued service, right? It's not something that maybe you finish the build, you have a point in time, but it's a continuous service, can be several years. So again, the advice, move or build, and then you end up in operate. And in operate, you have sort of these 4 pillars of support that I just mentioned before. And this is basically how we finish with our cloud journey. So I think that's pretty much for me today. Then we have additional presentations that the team will continue during this during the different talks we have out of the day. So thank you so much for your time. I hope you find it interesting. Again, as I mentioned, I encourage you to download the white paper that we have put together. We'll be sharing the link. It's public. It's in globant.com, and you can share it with your clients. I think it's a really good way, and it will be faster than this presentation, so you can read that and you will also have a pretty good understanding of our approach. Thank you so much, and talk to you next. Bye-bye.
Thank you, Facundo. That was an amazing session.
It's really good to know how this cloud transformation framework is helping organizations to migrate their workload on cloud.
Now, it's my pleasure to introduce our next presenter, who is Anand Kumar Jadav. He is Technical Director at Globant, and he has over 15 years of industry experience specialized in cloud consulting, Azure and AWS cloud administration, AWS cloud migration, application performance management, security and cost optimization, PCI compliance on cloud, and other DevOps areas.
Anand will be presenting about DevOps Toolchain Provisioner, which helps us in provisioning well integrated and secure toolchains on clouds like AWS, Azure, GCP, or on-premise. Welcome, Anand.
Hey, hi all. This is Anand Kumar Jadav. I'm a technical director in Globant. Uh, let's start with the presentation. So today we are going to discuss about tool chain provision, and we are using this for infrastructure provisioning and tool provisioning. So before we look at what the problems that comes in mind to come with these solutions. All right, let's understand the agenda. So we are going to discuss the context behind this toolchain provisioner. What is toolchain provisioner? Then the end users who is going to use it, the component or building blocks that we are using for this toolchain provisioner, then functional flow, architect, which we have deployed on Kubernetes, then application demo, then capabilities and quality attributes. And then we can have some idea about the roadmaps that what we are going to implement in next phase. All right. So the context is like many times what happens is like organizations are trying to become agile mode, want to work in agile mode where they wanted to implement everything like infrastructure and tools very fast so that they can focus on the development side and they can deliver their project very fast. Now here main thing is like we need to provide such talents where they know the tools, plus they need to configure those tools so that it will be available in few minutes or few hours so that developers will start using that, right? And the main problem here is are not capable to invest such amount to have those tools available in few days or few hours. Then most client and DevOps sources go through the same learning journey and common mistakes. So if there is a same tools that they are going to use for multiple customers, then there is a possibility that there could be a mistakes because we are trying to do this manually. Then community or free solution that we need to target. Most of the solutions are paid ones. Then end user cannot focus on the software development. They are because they need to think of infrastructures and tools and all. So after having some thought on this, we come up with these solutions where we try to offload most of the complex works in automation way, which create infrastructure which is common for all maximum stacks. Then end user can focus on the software development. Most of the part will be handled by GUI based, so user don't need to understand what is the scripts or what is the program that we are running in the backend. And of course, well authenticated. It may be AD specific or organizational specific authentication that we can implement. And also all type of infrastructure, maybe it's cloud or on premises. So you can say multi cloud or hybrid version also. All right. So let's understand what is tool chain provisioner. So the tool chain provisioner is a tool which provision very integrated and secure tool chain on cloud, AWS, Azure, and GCP or on premises. So these tools is actually provision infrastructure as per the tools requirement, and it deploy on the given cloud or on premises environment, and within a few minutes you can start using those tools. For example, if you wanted to create a CI/CD pipeline for an application which is like Jenkins, then you need a SonarQube, then you need a Nexus and GitLab. In that case, you need to provision infrastructure plus you need to configure those tools. So it takes some time or you need some expertise to provision these tools. So exactly this tool chain provision is doing all these work seamlessly. You don't need to worry about the configuration and infrastructure which is required for those tools. In a one click, you can provision all these infrastructure and you can get the links and URLs directly about that tools, and you can start using that. Right? These tools has an attractive dashboard to have an insightful look at the progress of infrastructure setup as well. Okay, so let's move ahead and see who can use this toolchain provisioner. This product automates much of the user's tasks, thus increase productivity. Right? Toolchain provisioner supports use case that are key to the customer's overall business process and is very easy to use. So you will see a UI where you just select a template, and it template will be the collection of tools, and at the end, once you deploy that template, you will see all the tools deployed on an infrastructure and you can start using that. Right? So all the DevOps engineers, architect, or any application user, they can use this and they can deploy these tools and they can start using it right away. Okay, then let's understand the component that we are using here for this toolchain provisioner. So we are using UI and UX, which is in AngularJS. All the customers or users connect with the UI, which gives you the whole idea about the templates and tools that we are using. Then it's back to the send request to the backend, which is consist of Java APIs. Actually, it's a microservices which consist of all the functionality which is required for infrastructure provisioning, tools management, template management, then execution of tool installations and queue part. Okay, the third comes the database. Now here we keep information about all the tools, the templates that we have created, the mapping between the templates, then information about the users and the template or infrastructure that they have created. Then we have a bridge or queue, which you can say kind of a Jenkins CI, where we are sending request to that Jenkins server, and that Jenkins is having multiple jobs. One job might be create an infrastructure on AWS. Then one job would be like install tools, let's say Jenkins or SonarQube. Then there are multiple jobs which actually having all the templates which create infrastructure, configure those tools, and install those tools. Okay, then we have multiple libraries which are consist of Terraform, Shell script, and Ansibles. Okay, so infrastructure provisioning, we are using Terraform, which is having different libraries that we have created for AWS, Azure, Google Cloud, Oracle, and on-premises environment as well. For example, Vagrant. Then infrastructure configuration. So we have scripts which configure this infrastructure in between. Say two servers are running, and the connectivity and VPC configuration, subnet configuration. So such configuration we do through this infrastructure configuration library. Then we have a tool installations. So these libraries are for each and every tools that is required for the templates. So it is in a shell script or PowerShell. So as per the requirement, like the OS that we are having, so on that basis we are having Docker images, shell scripts or PowerShell script to install the tools, and the tool configuration scripts which are used to configure two different tools. For example, Jenkins and SonarQube. So it automate that configurations, or let's say a particular application need Java CI/CD pipeline. In that case, if you want a Java plugin or extension to be installed on Jenkins, so this kind of tool configuration we already automated. So it will start deploying and installing those tools, and you can start using right away. Okay, and it connects to the infrastructure providers, where like we are implemented multi-cloud solution. So right now we are having AWS, Azure, GCP, Oracle implemented, and also Vagrant on-premises solution for this. Okay, I hope you understood the building blocks. Let's move ahead. Now let's understand the functional flow of the applications. As I told you, we are having a web UI where users select the template and send that request back to the API. Now, if you look at the diagram, we are having a API server running, and in that API server, we are having multiple microservices, APIs, which actually execute uh, scripts that we are having in different libraries. So let's have an example. If we wanted to create an infrastructure including to Jenkins, SonarQube, and Nexus, and GitLab. Okay, so that request will send it to the API server. Then API server will call a library to create infrastructure. Now, this infrastructure information will be there in the template of infrastructure templates and the database. So database will have the information about the mapping of the tools and their scripts related information. And in the library, you will see all the scripts that is used to implement or execute those infrastructure. So all these scripts or libraries will be executed through this API server. Now, if you look at the diagram, you can see we are trying to execute Vagrant template, which create infrastructure as a virtual box on-premises environment. So once we call this Vagrant template, it create infrastructure on-premises environment, and then we install tools through Ansible scripts. So we are having Jenkins playbooks, SonarQube playbooks, and Nexus playbook. These APIs execute those playbook on those newly created virtual machines and start installing those tools. Then at the end, the tool and infrastructure discovery. Now this is one of the unique library or API we have, where we actually trying to understand the existing infrastructure, and on that basis we keep important information in the database. Say for example, like how to connect with the installed tools. Say if you install Jenkins, then we have all those information. We discover that information that the IP address of the Jenkins tools and the port, so that the customer can start using installed tools right away through that IP address. So this information will be discovered and stored in the database. So whenever you log into the toolchain provisioner, then you can see all those links and you can log in from there as well. Okay, so now it provides the flexibility for user to select their choice of public cloud platform as well. So right now in the example, we are using on-premises environment, but at the API level, you can choose which cloud you want to deploy that infrastructure and tool. Okay, let's move ahead and understand the architecture. Now, this architecture, if you see that we deployed toolchain provisioner on a Kubernetes server. Now, this is one of the client requirement that they wanted to run this toolchain provisioner on Kubernetes. So, this tool is running. We have all the images running on the registry, and from there we are running this UI, API, and database in a Kubernetes cluster. So high availability is already implemented, auto scaling is already there. So if all the requests, if there are a lot of requests, it keeps managing those requests through this Kubernetes cluster. Now if you look at this, we are created API pods where all the API is running separately in different pods, and also the scripts that we are using for Terraform and infrastructure provisioning and tool installation, those are also running in different containers, okay, in a pod. So all those script will store in a persistent volume, and from there it try to execute for each request. It execute those script and create infrastructure right away. So at the end you can see these are connected with the AWS infrastructure and creating VPC with virtual machines. So you can see that inbuilt security also we are providing through this tool. Okay, and while execution we are using the storage of their storage from their cloud, and from there we are executing those script. Okay, let's move ahead and let's have a demo of this application. So you can see that this is our login page. So you can see we have a customized logo. Then this is the sign in Google account. So you can use your own Google or AD, personal AD or authentication system. It's configurable, so we can customize this more. Okay, so let's sign in. So I'm logging into this system through my organizational credentials. So once I log in, you can see the landing page. Now you can see that this is the section where you will see the deployed infrastructure. Then these are the existing template. As I told, if you can see here, DevSecOps projects where we are giving this template with including tools like Jenkins, GitLab, OAuth, SonarQube. Same with Java applications. This is simple CI/CD project where CloudBees, GitLab, SonarQube, and JFrog we are providing. And this is the ELK template. So these are a few predefined template right now we are having, and these are the list of tools that we are using. Okay, so GitLab, Jenkins, artifact management tools, then quality using SonarQube, then monitoring, security. So you can have more tools added. You will see more tools added in this system. Okay, let's go ahead and let's try to create a simple project. Okay, so we can go here. Let's create this project. So in this script, you need to mention the project name. Okay, CI/CD prod. Then next, Now in this screen, you need to enter the configuration that is required. So let's check the Jenkins. So you need to add the root username and password. Okay. So let's add admin 123. Okay, these are the root username and password for Jenkins. Then GitLab, it's a SaaS solution, so you need to register with the GitLab, and you can configure that with CI/CD tools. Let's continue. Then SonarQube. Then again, let mention that admin hash 123. Say for example. Then continue. Then it will ask for the Nexus credentials. So Nexus admin 123. Okay. So once you save that, it will ask for the next. Okay. So next. Now you can see this is the next slide screen. You can configure cloud. So it will give you right now. It is gives you 4 different clouds. So AWS, it will ask for access key and secret key. Now it is required some access which create infrastructure and install the tools. So minimum at least we need EC2 instance access, VPC access, and S3 access, where it can create infra and deploy the tools. Then Google Cloud, same way you can provide the required permissions with the credentials. Then Azure, the required information, then Oracle. Okay. So once you added these credentials, okay, and the bucket. Save and next. Okay. Now in this screen, you can see the review of the infrastructure, how this toolchain provisioner is going to deploy the virtual machines and the tools. So in this case, it is going to create 4 different virtual machines, and each virtual machine will have 4 different tools will be installed. Okay. And once you deploy, it will start processing it, and in the back end it will start installing these tools. So you can say infrastructure provisioning plus tool installations. All right. So it's again come back to the landing page, and you can see the progress of the CI/CD project, and also you can see the logs from here. Okay. So this is how you can control your infrastructure and your deployments. Let's understand the capability and quality attributes of this tool. Okay, so you can see that as per the demo, you can see that like infrastructure creation and deletions is via single click. You can manage it well. You can see the list of infrastructure created, and also the existing template that you can create in future. Then the list of tools is already there. You can add more tools as a plug and play. Say for example, if you wanted to add a cloud b to you as a tool, then you don't need to write a special say different program for this. We will have a simple installation script which will be added as a script in this tool, and this framework is actually consume that script, and you can use it in whenever you want. Okay, so there are few entries that you need to make it into the database, and it will be visible and enable to use it in templates. Okay, it support multi-cloud, built-in standards like security and automations, predefined templates. As per the best practices, we try to create predefined templates. Say for example, CI/CD pipelines that we are required for Java application, .NET application, Node.js applications. So you can have a CI/CD pipeline. you can have a template for DevSecOps solutions. So OAPS is already there in the template. Then we are having other templates where you need to monitor some or logging some applications. So ELK specific templates is also there. So you can have these templates and you can use these templates and you can execute whenever you want in a one click. The authentication mechanism we already implemented. Right now it's connected with the Google, so you can add your own organizational basis authentication as we are using API, so it's more easy to configure new authentication uh, uh, so that you can add more into that. Then auditable states of infrastructure in the form of remote Terraform state. So we are storing the state of infrastructure in their storage account. So they will know, the customer actually, they will know like what kind of infrastructure that we have created and what we have deployed there. So that state you will see there in this storage also. And this tool is refer that state files, and these tools can update or configure that tool infrastructure. Now the qualities, it reduces time to provision DevOps infrastructure because once you click on the deploy, it's running in the backend, and within a few minutes you can see that running tools available. Built-in standards, reduce learning curve for the lesser experienced resource because they don't need to understand the configurations and all. Then it's a harvest learnings into an asset. You can say like this: if you have people wanted to learn these tools, you can launch these templates and you can give access to those tools and they can learn it. And after that, you can destroy those templates, which will have more control on this. Then predefined and user defined templates, then infra templates. Okay, so infra template, it means like we already have a built-in security implemented. Say for example, on Azure, AWS, we have scripts which are create VPCs and subnet and their security. And on Azure, let's say we are creating VNets and their subnets and the connectivity between two different subnets, and well secure through best practices. Okay, let's move ahead and see the roadmap. Okay, so there are many things that we are adding here. Say adding new open source tool, then REST API, which we are going to open so that other application can try to access this REST APIs. Then command line prompt, which can be uh, create infrastructure. If you wanted to use command line tool, you can use that. Then PaaS services integration. So right now we are creating virtual machines, so we'll have SaaS products where you can deploy these tools. So for example, Kubernetes. So if you wanted to deploy Jenkins and other tools on Kubernetes cluster, we are going to provide that. Then application stack deployment. So if you wanted to deploy end-to-end infrastructure for an application, so it is possible through this tool chain provider, where the end-to-end application infrastructure plus application, and it will also deploy applications. So that are in our roadmap. Then admin panel, definitely there will be a panel where you can create new templates, add new templates, or customize templates, add new tools through a UI panel, and you can enable or disable templates or tools. Then libraries, additional libraries as per the requirements. So right now we are having Azure, AWS, Oracle, and GCP. So we are planned to add for Alibaba, IBM, Rackspace, or Google, data center specific libraries. Then libraries for configuration management. So right now we are using Ansibles, but this will be as per the requirement. Say if someone asks to use a chef instead of Ansible, so that those libraries that we are going to use, as you know that it's a plug and play kind of things. So if you have chef libraries ready, then user can decide like which libraries they are going to use for infrastructure provisioning plus configuration of the tools. Then libraries for IaaS, if they want native solutions, then ARM templates or AWS Cloud Formation stacks that we are going to use. Then if there is any monitoring or VMS integration, so again, it monitor the deployed infrastructures, and VMS integration is actually gives you the idea about the automations, the infrastructure and their performance. Okay, so you can see that there are many things that we are going to implement as a framework. Then look at the functionality. So admin panel, as I discussed, like OS templates and tool management. Then infrastructure discovery. So right now we are creating infrastructure, but there will be a discovery where this tool will discover the existing infrastructure, and you can have a choice where you can select the infrastructure and you can deploy those tools. Then uh, tools and template management for customer. Then we will have a virtual command line panel. So on the website itself, you will see a command line tool where you can manage install tool. Okay, so if you wanted to configure Jenkins in more advanced level, so this virtual command line tool will connect you to the install tool and you can configure that. Then template deployment and serverless architecture deployments and automation to manage custom network. Okay. All right, great. So I hope you understand the use of this tool chain provisioner. If you have any questions, please share your questions to me. Thanks.
Thank you, Anand. This is very interesting indeed.
Exactly, Anjali. The next session is about architecting applications for multi region deployments. The session will be all about how to deploy your mission critical application on AKS multi region to achieve 99.99% availability.
Our next presenter has 15 years of experience in leading large-scale cloud infrastructure development projects in emerging technologies. Let's welcome Vipin Pandey, a cloud architect at Globant.
Hello everyone, good morning and good evening. So my name is Bipin and I am working at Globant as a cloud architect. So if I talk about my experience, I am having 15 plus years experience in IT. Since last 8 years I am in cloud. So today I am going to talk about how to deploy your mission critical application on AKS multi-region cluster deployment to achieve 99.99% SLA. So in this session, I am going to cover first thing is use cases where we can use AKS multi-region deployment, architecture overview. So it's like Azure Kubernetes service, Azure infrastructure components, DevOps strategy for Azure Kubernetes service and application, high level design Azure SQL database, high level design audit log solution, and in the last, I am going to talk about challenges and solution. So potential use cases are, okay, so how to design and implement a solution to host an application on microservices with high availability and disaster recovery. So deploy mission critical application running on Windows or Linux containers. So improve user experience by keeping your application available 99.99% time. So what we can do is we can plan for multi-region deployment. So it is better to choose region close to your users, and for your geographic area, choose two regions paired together. So what we are going to get benefit if we are going to use two regions paired. So if that Microsoft is going to do AKS platform updates, so it would be delayed at least 24 hours between paired region. So next I can talk about service availability. Decide whether your paired region should be hot warm or hot cold. So do you want to run both region at the same time with one region ready to start serving traffic, or do you want to give one region time to get ready to serve the traffic? So if we talk about architecture diagram, so this is a very high level architecture diagram where we can talk about how we are going to deploy AKS multi-region cluster. So here we can see, so this is a Azure US East 2 region and Azure US Central. So we are going to deploy AKS cluster in two regions. So first one is US East 2 and second one is US Central. So if we talk about Azure Kubernetes service components, so here we are going to host microservices. So we can host multiple microservices container within the pod. And also if we talk about communication, so here we are using Istio ingress controller, which is responsible to route traffic from the Istio controller to appropriate microservices. So also we are using ingress load balancer. So ingress load balancer we route traffic from load balancer to ingress controller. So if we talk about overall design document, so here for routing we are using APG as cloud. So APG as cloud is responsible to route traffic in both the region parallelly. So you can see like traffic is routed to primary region and secondary region as well. And after that, Azure Ingress is responsible to route traffic to Ingress load balancer, and then Ingress load balancer will route traffic to Ingress controller, and then Ingress controller will route traffic to microservices. So for storing microservices data, we are going to use Azure SQL Server database in geo replication mode, and also we are going to use Azure Redis cache geo replication to store data in time memory. So if we talk about other services, we are going to use Azure Key Vault, and where we can securely store our secrets and can access. And Azure Container Registry is Microsoft hosted platform where we can host our Docker images. So this is the overall design document for how we are going to deploy Azure Kubernetes services in multi-region. So here I'm not going to talk about foundation. So we are assuming that cloud foundation is already in place. So if we talk about Azure infrastructure components, then Azure Kubernetes service. Azure Kubernetes service is managed container orchestration service and based on open source Kubernetes system. Second, we are going to use Azure SQL database to store database, and it is a managed cloud database provided as part of Microsoft. So second thing is we are going to use other services as well. So we can talk about Azure Key Vault. Azure Key Vault is a cloud service for securely storing and accessing secrets. Azure Container Registry is Microsoft on hosting platform for Docker images. So if we talk about Azure Cache for Redis, so Azure Cache for Redis provides an in-memory data store based on the Redis software, and which we are going to use for storing data in memory. And for service mesh, we are going to use Istio. Istio is an open source service mesh, okay, which provide efficient way to secure, connect, and monitor services. So for multi-region routing, we are going to use APG Edge Cloud, APG SaaS, and APG Edge is a platform for developing and managing APIs. So APG will be leveraged as a regional load balancer to route traffic between the regions. So these are the infrastructure components we are going to use. So if we are going to talk about how we are going to deploy other services by using Azure Devops. So we can use Azure Devops, we can integrate Terraform or ARM template, we can create CI/CD pipeline to deploy infrastructure, and also we can create a pipeline for application deployment. So first thing is, if we talk about Azure DevOps, then once code is ready with the developers, so developer will push code into the Azure repository, and after that pipeline will get triggered. So once pipeline will get triggered, it will, in the build phase, it will create a Docker image, it will scan the Docker image, and after that it will push Docker image into the Azure Container Registry. So in deploy phase, Helm chart, we'll use Helm chart to deploy the services within the AKS cluster. So this is the high level design, how we are going to deploy code into the AKS cluster. And if we talk about branching strategy, so developers can use feature branch to develop their code. So once code is developed, they can push the code into the development branch, and once code is available in development branch, after that developers can push code into the quality and assurance branch, but there should be approval in place. It should be approved by developers lead. So once it is approved by developers lead, that code will be pushed into the QA environment. So once testing is done in the quality and assurance environment, so that quality and assurance team will do the testing, and they will make sure that code is good and it can be pushed into the UAT environment. So then we'll can use release pipeline to push code into the UAT environment, and where we are going to do UAT development, then pen test, and then performance lab. So once complete testing is done into the UAT environment, then we can push code into the production environment by using master pipeline. So this is the overall Azure DevOps high level design document, which we can use to deploy infrastructure as a code or application code. So here we can talk about how we can deploy AKS multi-region cluster and other infrastructure components. So we can use ARM templates or Terraform to deploy AKS multi-region cluster and Istio configuration via Azure DevOps pipeline. And we can use ARM template or Terraform to deploy Azure SQL Server geo replication with auto failover group via Azure DevOps pipeline. So rest of the resources also can be deployed in same manner by using Azure DevOps pipeline. So if we talk about production environment, so in the production environment, we will have two AKS cluster. So how we are going to deploy parallelly in both the region. So we have to modify or update the pipelines. So that pipeline should be able to deploy code parallelly in both the regions. So we will have latest code available in both the regions. So that's why we need to create and update pipeline which supports both the regions deployment. So here if we talk about high level design for database, we are going to use Azure SQL database active geo replication. So in active geo replication, it will be deployed in two regions. Okay, one primary region and secondary region. Here we can say East US 2 and Central US. So primary region, so database can be read and writable, but secondary region database will be in read mode only. So we have to route traffic. Read and write traffic we can route to primary region, and read traffic we can route to secondary region. So let's assume primary region goes down, then all the traffic will be routed to secondary region, and APG gateway will make sure that all the traffic is routed to secondary region. And also we have to plan for the resources which can support traffic uh, routing. So if we talk about how we are going to do that Azure SQL database active geo replication, then it support, you can use active geo replication to create a readable secondary replica in different regions. Also, we can use active geo replication can be configured for any database. The auto failover group features allows you to manage the replication and failover of a group of database on a server or all databases. So you can initiate geo replication failover manually, or you can delegate it to the Azure service based on user defined policies. So if we talk about that recovery method, okay, so if we are going to use geo restore from geo replicated backups, that restore time objective is 1 hour, and restore point objective is 1 hour. Auto failover groups restore time objective is 1 hour, and restore point objective is 5 seconds. So if we are planning to do manual database failover, then RTO is only just 30 seconds, and RPO is also only 5 seconds. So but we have to automate this solution, so that's why we are decided to use auto failover groups. So once your code and application is deployed into the AKS, the next step is we need to think about audit log solution, how audit log is going to store and going to manage. So here we talk about that Azure Kubernetes service, that we can see that microservices MS1, MS2 is already deployed in the environment, and we are using logging bucket packet to push audit log data into the event hub. So once data is pushed into the event hub, we can use stream sets. So stream sets integration service which will pull data from the event hub and push into the Snowflake data warehouse. So this high level approach and design is for audit log solution, and this is very high level. So if we are going to talk about each and every components, okay, so logging nugget is responsible. So the audit log information, okay, sent from microservices to the Azure event hub service using the logging components consume as nugget. And event hub is a streaming service for data injection purpose. So we are using event hub here for streaming and for data injections. And if we talk about the stream set is ETL cloud based solution to integrate Azure event hub and Snowflake. So once stream set is integrated with Azure event hub and Snowflake, then stream sets will pull data from the Azure event hub, and it will be pushed into the Snowflake, and all the audit log information will be stored in the Snowflake. And if we talk about Snowflake, so Snowflake is a data warehouse cloud based solution to persist the audit log events. So all the audit log events will be stored in Snowflake. So this is what I was interested to talk about. And in next slide, I can talk about challenges and solution. So what challenges we faced while deploying this solution? So first challenge was design and implement of a solution to host mission critical application on microservices with disaster recovery. And solution we provided to client that AKS multi-region deployment active. So second challenge was the design and implementation of a solution to have balanced traffic across multiple regions to achieve fault tolerance. So we set up APG gateway with weight-based routing rules to route traffic either services on Azure regions. So if we talk about third challenge, then it was design and implementation of solution to store audit events from all microservices for large period of time. So we set up Azure Event Hub, Stream Sets, and Snowflake to store audit logs for all microservices, and each and every components was integrated with each other. So SQL database, so write on primary only and control it through traffic manager to achieve strong consistency. So we use SQL database which support 99.995% SLA, also active geo replication and auto failover group. So I would like to thank you guys for your valuable time.
Thank you, Vipin.
Thank you everyone for such an inspiring first day here at CloudNext 2022.
Yes, truly. That was a wonderful day with so many knowledgeable sessions.
We look forward to seeing you tomorrow, where we'll be talking about chaos engineering, immutable infrastructure, Globant's DevOps maturity model, and GitOps, ChatOps, and GitHub Flow.
See you tomorrow, folks.